Hello and welcome to lesson 12.4, Measures of Spread. Our objective for today is that I can determine measures of spread, including the range and the interquartile range of a set of data. So let's start by defining what a quartile is. A quartile, quart is the prefix there, is dividing the data set into 4 equal parts. If the data set has an odd number of entries, then the median is not used or not included when finding the quartiles. Interquartile range is the difference between the first and the third quartile. So what this means is it's the middle 50% of your data. And here we have our examples of quartiles. We have our minimum, that's your lowest value. Your maximum is your highest. Your median is your middle value. It is also the second quartile. Then you've got quartile 1 and quartile 3 are your outer quartiles. In your interquartile range, you do quartile 3 minus quartile 1. And then we have a box and whisker plot. A box and whisker plot is a graph that summarizes a set of data by displaying it along a number line. So let's go to example 1, measures of center. The first thing we're going to do is find the median. The second step we're going to do is create 2 data sets, a lower data set that is all the values less than the median. The upper data set is all the values greater than the median. You're going to find the median of the lower data set, that gives you quartile 1. You're going to find the median of the upper data set, quartile 3, and then to find the range, you do Q3 minus Q1. So I've already set up the data for us for our orders. So we need to find the min, the first quartile, the median, the third quartile, and the max of the data set. So you start by putting it in numerical order. And our min is 60. Our max is 105. So those are easy to find. We have a total of 11 data points here, so we're going to go to our 6th. So 1, 2, 3, 4, 5, 6. That's our median. Now we have an odd number of data points, so we're going to look to the left and to the right of it. So to the left, we have 1, 2, 3, 4, 5 values. So my median of this one is 75, and so that's quartile 1. That's Q1. Then you look to the right, you have another 5 values, and we find the median there, and that's quartile 3. So then to do the interquartile range, you do 95 minus 75, and you get 20. All right, so let's take a look at another data set. This one only has 6 values in it. So we have our min and our max. Those are easy to find. To find our median, you need to go to your center. And so we have 2 terms in the center. So you do 11 plus 19, and you get 30. 30 divided by 2 is 15, and that's your median. So we look to the left of the median. We have 3 values, so it's going to be the middle, so that's Q1. We look to the right of the median, and we have 3 values, and it's 21 is Q3. Then the interquartile range is 21 minus 7, which is 14. Now, why did I include, I don't want the lasso tool, I want the laser tool. Why did I include these 2 values, when I look to the left and look to the right? Because they're not actually the median. The median is in between those 2 points. And in our directions, we said if there's an odd number of entries, the median is not included when finding the quartiles. So we had an even number, so we do include the numbers on either side. All right, our next data set, we have what are the minimum, maximum, and our ranges. So our min is 49. Our max is 111. We had 8 total data points here, so we need to do the middle 2 and find the average of them. And so 64 plus 78, and then dividing it all by 2 is 71. That's your median. And then we look at our left side. We have an even number again, so I need to find the median or the average, the mean of 55 and 56. So we have 55.5, which is quartile 1. On the right side, we have 4 values to the right of the median. So we again need to do 101 plus 108 and then divide it by 2, you get 104.5, which is our Q3. And then interquartile range is 104.5 minus 55.5, which is 49. All right, let's take a look at the next page. There are 3 U-try problems. Do those on your own and then check your work against mine. So numerical order already. We have our min, our max. There are a total of 8 data values, so we need to find the median, which is going to be the middle of the average of these two, so that'll be 23 is our median. To the left of the median, there's 4 values, so I need to take the average of 15 and 19, and I get 17 for Q1. Take the average of 27 and 33, and I get 30 for Q3. And then your interquartile range is 30 minus 17, which is 13. Letter E. Our min is 4. Our max is 34. We have a total of 12 values, so we find the average of 14 and 15 in the center there, and we get 14.5 is our median. To the left of the median, we have 1, 2, 3, 4, 5, 6 values, so we need to find the average of 8 and 9, and we get 8.5, which is quartile 1. To the right, we take the average of 25 and 31, and we get 28, which represents quartile 3. So then our interquartile range is 28 minus 8.5, and that's going to equal 19.5. Our last data set, it's a large one. We find our min. We have our max. There are 19 total values, so we count to the 10th one, and it's that one right there. There's our median, 59. And then on the left of that, we have 9 values, right, to the left of it. So the median of that is 36. We have 9 values to the right, so the median of that is going to be the first 67. And then interquartile range is going to be 67 minus 36, which is 31. So now example 2 is make a box plot. A box and whisker plot is a graph that summarizes a set of data by displaying it along a number line. It consists of 3 parts, a box and 2 whiskers. So the whiskers extend from Q1 to the min and from Q3 to the max. The box is made up of Q1 to Q3, and it also has a line separating out the median, Q2. So we want to make a box and whisker plot of the monthly sales data that we have there. So we're going to have a line and we're going to put some points along it. So we're going to have a 4, we're going to have an 8.5, and I'm going to just, this is a big spread, so I'm just going to make some approximations. So my min is 4, my max is 34. Okay, so that covers that, min, max. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8. So we need to find the average of 14 and 15. So our median is 14.5. So that'll be that. And our quartiles, we're going to find to the right of that, which is going to be the average of 16 and 25, which is 20.5 is quartile 3, and 8.5 is quartile 1. And so when we graph it, we have a dot there, a dot there, a dot there, a dot there, a dot there. We have our whiskers that go to the outside, and then we have our box that we set up like that. All right. So down below, we've got runners in a 9 runners in the 200, and we want to make a box and whisker plot that represents the data. So we have our min, our max, our median is 34, and then we have 1, 2, 3, 4, so we need to have the average there, which is 32.5, that's Q1. We take the average there, which is 37, is Q3. And now we make our box and whisker plot. So we have a number line, and we're going to do 30. So 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Don't need 41, but we're going to use it anyways. So we place our max at 40, our min at 30, our median at 34. We have our whiskers, 32.5, which is going to be like right about there. We have a whisker at 37, which is right there. Sorry, we have a median. Quartile 3 is right there. So now we draw in our box and whiskers. So the whiskers are on the outside. The box is the middle portion. And there we go. We have our box and whisker plot. All right. There are 2 U-try problems. Please do those on your own and then check your work against mine. Letter C, I gave you a financial analyst for a movie studio wants to determine how much of the top earning movies have grossed compared to the studio's recent grosses. The worldwide gross in millions of dollars for the top 10 highest grossing films of all time are given. Create a box and whisker plot to represent the data, and we're going to go ahead and see what it is. So we already have it in numerical order. It's just reversed. It's starting at the high end and it's going down to the low end. So on the left, we have our max. On the right, we have our min. Top 10, so we need to find our average of 1520 and 1516, which is 1518. And then we find our quartiles, which is 2060, Q3, and 1340, Q1. And now we need to make a line. And we're going to do our best with this. We're going to go by 100, so we're going to say 1200, 1300, 1400, 1500, 1600, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So our line's going to go all the way out to there. My scale's not perfect, but we're going to work with it. So we're going to put in our maxes and mins. So our max, we have a point out here. Our minimum is at 1215, so that's going to be over here. Our median is at 15. So it's going to be something like right there. Quartile 1 is at 1342, so that's going to be thereabouts. And quartile 3 is at 2060. So it's going to be something like right there. So now we draw in our box and whisker plots. And what does this tell us about the data? Well, it tells us that we have a massive spread in our middle 50% of the data. The middle 50% of the values, we have a huge spread. We've got much more on the right than we do on the left. So we are definitely skewed, and we've definitely got some outliers compared to all the rest. One of them is making $2.788 billion. $2.1 billion, and then you're going down to 1.2 billion. So your max is twice your min. So we see a lot more variation on that high side than there is on the low side. The low side's much more compact. All right, letter D, we're going to look at the average age in which women get first married in different countries. The age for 8 countries are shown below. So we have our min, we have our max. Our median is going to be in the middle of this data, so it's going to split 26 and 27, so 26.5. And then our quartiles is going to be the average of 21 and 25, which is 23. That's Q1. And we take the average of 29 and 31, which is 30, which is Q3. And now we have to graph this on a number line. So we've got, we're going to start at 20, so 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. All right, so we're going to put our minimum, 20, our maximum, 31, our median, 26.5. We have quartile 1 at 23, quartile 3 at 30, and then we make our box and whiskers. And there we go. So now, interpreting box and whisker plots, we're going to use the given box and whisker plot and figure out what do the interquartile range tells us. So what does it tell us for Miami? The interquartile range is from a little less than 2.5 to a little more than 7. So half the rainfall in Miami ranges from 2.75 to 7.25 inches. What does the interquartile range tell us about New Orleans? Half the rainfall in NOLA is between, that one's going to be what, 4.75 approximately, and 6. inches. So we could say, we could also just look at the whole box and whisker. Um, New Orleans, so NOLA, has a higher median, but Miami has more variation. All right. 2 U-Trap problems on the next page. Let's take a look at them. Which species, so we have the box and whisker plots below, which species has a greater range in average length, and which species has a greater interquartile range. So greater range is species A, for sure. But greater interquartile range is going to be species B. So B for that one, A for that one, right? Because we can see the interquartile range of species B goes from 65 to like 82, 83, whereas the interquartile range for species A is 67 to maybe 77. So it's a much narrower span on the interquartile, the middle 50%. But the extremes on species A can be wider than the extremes on species B. And use the box and whisker plots below. What does the interquartile range tell you about the average height of children in the study? So what does it tell us? Well, we see that we've got height of girls and heights of boys. Boys have a much, much bigger range of values. They also have a bigger interquartile range, right? It's a big spread for boys. Girls are much more compact in terms of their height distributions. So half the height of girls range from 66 through 69 inches, and half the range of boys is from 65 to 70 inches. So we also see, the high end is much higher than the third quartile. The low end is much lower than the first quartile for boys. Girls, it is a much more compact distribution in this particular instance of these grades. So that is the end of our notes for Module 12.4. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.